All right, said I was going to post a video for working out the homework tonight to study for our quiz tomorrow. This is going to look, our quiz tomorrow is going to look exactly like this, except you'll actually only have one of these kinds of problems, okay? So don't cross out yours, still use it for practice. If you can do all these, then you're fine. So number one says, well, 1 and 2, write the prime factorization of the number. Prime factorization, really focus on the idea of primes. We're going to make these trees with many branches and go down and stop at our primes. And then we're going to write down the way to multiply using primes for our final answer. So I can start with any way I want, but I can never put a 1 in here, because if I put a 1, it could go on forever. Like imagine 15, 1 and 15. 1 and 15, 1 and 15. You know what I mean? So we cannot use 1s in this. And if we can't use 1s, you can't use the original number. So what's another way to multiply to get 15? 3 times 5. So what I do is I circle my primes because those are dead ends. Is there a way to multiply 3 except for 1 times 3? No. Is there a way to multiply to get to 5 except for 5 times 1? No. These are both prime numbers. And so really I'm done. I can't go any lower. That happens to be 2 dead ends. So my answer would be 3 times 5. And here's an example if you need exponents later. 28. When I see 28, I'm thinking 4 times 7. So do that, 4 times 7. Are either of these prime dead ends? 7 happens to be. Your main primes, remember, are 2, 3, 5, 7, and then 11 and 13. And of course there are more after that, but I always think 2, 3, 5, 7. Those are the ones that come up the most. 4 is not prime. The biggest mistake people make is saying that it is. But 2 times 2 can give you 4. And so that's our final tree version, but we need to say how many 2's are there. If I just wrote it out, I'd say 2 times 2 times 7, but I want to condense these into exponent form. It'll help my understanding, and it's just a shortcut. So 2 2's times 7 should give me 28. Find the GCF, aka greatest common factor, of 14 and 21. The safest, most consistent method is to do the rainbow, the double rainbow method. Obviously 1 times 14 works. I can tell it's even, so I can maybe get a calculator or remember that 2 times 7 works. And then I go through my other ones. Does 3 work? No, because 1 plus 4 is 5. Does 4 work? No, it's not a multiple of 4. Does 5 work? Nope. 6? No. And then I get to 7. Well, 7's already been used. I'm done. 21. 1 times 21, obviously. And then 3 times 2. Does 2 work? No, because it's odd. 3 does work because 3 times 7 works. And tomorrow I'm going to let you have a calculator. So say you're faced with this 21 and you're going to ask, is 5 a factor? And you've forgotten all of our rules. You can just say 21 divided by 5. If the calculator gives you another whole number, then yeah, that worked. But it won't. The calculator is going to tell you something like 4.2. So if you have a decimal, is that going to work? No. So these are the factors of 14 and 21. And now I'm looking for, again, the greatest, biggest, common, shared factor. Do they both have 21? No. Do they both have 14? No. Do they both have 7? Yes. That is the factor that is the largest that they both have. So I would say 7 over here. 14 and 20 really quick. Fortunately, I already did 14 here, so I can actually do a little cheat, just say 20. 1 and 20. And 2 times what gives me 20? 2 times 10. And then 3? No. 4? Yes, 4 times 5. And I keep talking about being in the middle. There's no other way for a number to like squeeze in here. So that's our finish. That's when we're done. So we got to look now. So 20, no. 14, no. 10, no. 7, no. 5, no. 4, no. And then 2. 2 is the biggest number that 14 and 20 share, so that greatest common factor is 2. This one, you got big word situation, bunch of gift bags. This person's got 20 lollipops and 16 Starbursts, and they want to make as many even gift bags as they can. And what that means, there's a lot of words here, but it's really just trying to say that in a bag you might have 3 lollipops and 2 Starbursts. If these were the same amount, 20 and 20, well, then you could obviously make 20 bags and then give each person one of each, right? So they're never going to ask us that. They're always going to be different numbers, so you're going to have some weird combo. So what we do is look at 20 and 16 and we say, well, the fastest way to do this is to figure out what's the greatest common factor of these two. When you see the numbers, you should have a guess. Like they're both 4s, you know? But do this to make sure, because some things like 16 and 8 are both also 4s, but that's not the biggest factor that those two numbers share, 16 and 8. The biggest factor would be 8. So you'd want to make 8 bags. We did that in class yesterday with candy bars and sodas. Anyways, 20 and 16. So 20, we've got 1 and 20. I mean, geez, I keep using the same numbers here. So I'll kind of glance up there. I don't need to do that one again. 1 and 16, 2 and 8, and then 4 times 4, my little weird thing like that. So do they both have 16? No. 8? No. 4 it is. So 4 is the greatest common factor, and that means that's the most gift bags this person can make. And really, what's the question asked? Let me make sure I answer the question. Joy is making these gift bags. She wants to make as many bags as possible, but they gotta have the same lollipops and the same number of Starbursts. She's got this and this. What's the most gift bags she can create? Well, that answer is 4, and really technically that's all you need. I like to examine though to make sure that I haven't lost it, and I'll say, well, here are the 4 gift bags. And if I did split them up, I would say, all right, what's 20 divided by 4? It's 5. So there would be 5 lollipops in each bag. And the L stands for lollipop. And then 16 divided by 4 for the Starburst, 16 into 4 groups is 4 Starbursts in each. And I just kind of go back through and say, does that make sense? And think about how close 5 and 4 are together. There's not a lot of room to sort of insert or divide anymore. If you had 2 even numbers, that's a huge clue that you could probably split it up into more groups. But I couldn't split this up into more even groups without cutting like my lollipops in half. What am I going to say, 2.5 lollipops and 2 Starbursts in a bag? No. So anyways, I just double check, 5, 10, 15, 20 lollipops, 4, 8, 12, 16 Starbursts, and we're good to go, okay? I'm going to go faster on the next half, just because I feel like this side explains most of the small details, we'll say. All right, 36, so it's the same thing, just different numbers. 6 times 6, neither are prime. 2 times 3, 2 times 3. And those are all primes. And what's unique about this is that it's the same example. It's 2 2s, so 2 squared, times 2 3s, so 3 squared. 44, 11 and 4 jumps right out at me. That's a prime. 4 is 2 times 2, 2 and 2. So I've got 2 squared times 11, okay? And the long form would have been 2 times 2 times 11, and we condensed that to call it 2 squared. We want to get used to that. Next, 15 and 35. I can guess it's going to be 5 because they're both n and 5, but I want to make sure. 15 and 35. 35 is a tricky one. There actually aren't that many factors for that. 2, no. 3, no. 4, no. 5 times 7, yes. 1 and 15, 3 and 5. The biggest number they share is, it is 5, but you want to double check. If you just guess, you're going to be wrong half the time. And when I say guess, I mean go with your gut. So 5 is that, GCF. 15 and 30, just look at it. Double 15, what is it? It's going to be 30. I have to do this anyways, though. 15, 1, 3, 5, 15 are the 4 factors for 15. 30 has many, many, many more, but watch when I'll stop. 1 and 30. I'm going to see, does 15 work? Because I know if I don't have to check 5 if 15 works. 2 times 15. I actually don't need to keep going with the middle because I already found it. This is as big as 15 will allow, so 15 and 15, that can be and is the greatest common factor. 30 lollipops, 36 Starburst. It's got to be 6, but I want to make sure. 30. Would you believe it? I think this, I didn't do that on purpose, folks, but it turned out pretty well to have this. Whatever. Okay, 30 is 1, 30, 2, 15, 3, 10, 4, no, 5, and 6. Those are all the factor pairs. 36 is 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 in the middle. I cross them out. No, no, no. These are all different. None of them are the same. No, and then I see the 6 just like I suspected. I'll do my little diet. So 6 now before I get, whoa, that's not 6. Get rid of this bottom part. Okay, so that is 6 groups. So I'll say 30 divided by 6 is 5, so I should have 5 lollipops in each group. And you will have questions like this, so it's fun to go through this too to make sure. And then 36 starbursts, 36 divided by 6 is 6 starbursts in each group this time. And I can just do that, and I can say, yep, 5 and 6 are so close. They're only one. It's almost like the fraction 5/6. I can't help it. It's like the fraction 5/6. You know you can't simplify it anymore because they're only one apart. It's the same reason you can't simplify 1/6 anymore because there's nowhere else to go. And some students are here, and I will stop my video now. And when they watch this video tonight, they're going to know who they are.